have some concept related doubt or related to this system?
No, about the question. Ma'am, I've shared the question in chat.
Okay.
Here one said R1, it has only in the cardinality of R1 is 2, and how can it be transitive?
The cardinality of R1 is 2. So, what is the
How
question?
will
I
it
can
be?
see any kind of screenshot here. Can you share it again?
Yes, ma'am, I've shared it.
But I can't see any screenshot here. Just share it again.
Okay, ma'am. Ma'am, can I share my screen?
I think you are not able to share your screen.
Okay,
So only host
I'll
can share their screen.
okay, ma'am.
So my screen is visible, right?
Yes, ma'am.
Shall we start? Anything, any doubts or else? Okay, I got the screenshot. So what is the issue here?
Hello, ma'am.
What is the
Hello.
issue here?
Uh, Ma'am, in question number 13 and
I
in
can,
14.
am I audible?
Yes, ma'am.
Yes, ma'am.
Yeah. Yes. So what is the issue in this screenshot?
Hello, ma'am.
Yeah.
Ma'am, in the question number 14.
14. Okay.
Ma'am, here R1, how will it be transitive?
Okay. So what is given here? A is the set of positive, even positive integer less than or equal to 20. Then we can determine what the set is, right?
Yes.
Yeah. So even positive integer which is less than 20, less than or equal to 20. So we have 2, 4, 6, so on, right? Up to 20. P is the set of positive integer less than 20 which are divisible by 5. That means B is 5, 10 and 15, right? Now what is
Yes.
R? R1. R1 is A belongs to, okay. And A is a factor of B. So if we take B as 5, B equals to 5, then what is A? Then what is A? Is there any possible A here?
No, ma'am.
So there is no such A. If we take B equals to 10, then A can be 2, right?
Yes.
Or
10.
If we take b equals to 15, then
None.
A, there is no such A. So basically our R1 is 2, 10 and 10, 10. Yeah. So what is your problem? What do you think? This set is transitive or not?
It's transitive.
It's transitive, right?
Yes.
So what is
Yes,
your
ma'am.
problem? You
No,
can
ma'am.
take it A, B, B, C. Then A, C should be in the
How,
set.
why would
And
we take it as a C again?
yeah, that can be done. That is no problem. There is no
Ma'am,
issue.
ma'am, R1 is,
It's not
I think,
transitive.
ma'am, the set you have made is not correct, I think.
Why?
Ma'am, because we have to take the numbers which are from 1 to 20 first of all, and then we need that A should be a factor of B. So there should be many elements in this set, not just these two.
How? How?
Ma'am, because for example, lesser number should be a factor of the greater one. For example, 4 could be a factor, 2 could be a factor of 4.
But
And the same as like,
listen. But B is from the set capital B, right?
yes, ma'am.
4 is not, 4 doesn't belongs to capital B. So here you have three options. That B can be 5, that B can be 10, or B can be 15.
Yes,
No
ma'am.
other options.
Okay,
So
ma'am.
if B is 5, there is no even number that divides 5, right?
Yes, ma'am.
If B is 15, still there is no number that divides 15, right?
Yes, ma'am.
Even if B is 10, then we have only 2 and 10, which divide 10, right?
Yes, ma'am.
So
Okay, ma'am. Okay.
this is what are R1s. Okay. So yeah, is it fine now?
Yes, ma'am.
Yes, ma'am. I only had the doubt that if we take 10 as B, then there's no C. That's why I was confused.
Okay, okay. So yeah, I think now it is clear for you, right?
Yes, ma'am.
So yeah, we can start with week 5 content now.
Thank you, ma'am.
So yeah, during you have already seen the lectures of week 5, right?
Yes, ma'am.
No.
Okay, so this is just a summary class for week 5. So in week 5, we covered some concept called function.
Yes, ma'am.
And here we have seen that one function, inverse function, exponential function, and then we have seen that composition of functions, right?
Yeah.
So if we use this notation, A and for B, that means A is subset of B, R, and B is subset of R, right?
Yes.
So if we take a relation just from A to B, this relation will call a function if it satisfies some condition. And here we will say if f is a function, then we will say A is domain of the function and our B is codomain of the function, right?
Yes, ma'am.
And if we calculate f of A, it is subset of B. It can be the whole set B, or it can be a proper subset of B also, right? This is basically the image of the elements of A under the function f, right? So that already you know. So yeah, we can compare something. If we have a function, this is our domain, this is our codomain. So from A to B, we have a function f. So here we suppose we have two different points, x1, x2, they are not equal. So two different point can go to a same point, right? This is valid, right?
Ma'am, can you explain from the starting? Actually, we are joining in statistics.
Okay.
I'm joining late, ma'am. Can you please?
Yeah, I just started. Nothing is. We have A and B, which is subset of R, and we take a relation F from A to B. Then we will say that A is domain of F and B is codomain of F. That you already know, right?
Yes, ma'am.
If we take f of A, this is basically the image of the elements of A under the function f. So it is a subset of B. It can be whole set B or it can be a proper subset of B. Okay. So if we have a function f from A to B, then A is the domain, B is the codomain, and f of A is the range. Okay. Range or image. Okay. So I think you know got the difference between range and codomain, right? What is range and what
Yes,
is
ma'am.
codomain for a
Ma'am, the
function?
range is a subset of codomain actually.
Yes, range is a subset of codomain. Yeah. So this is the difference between range and codomain for a function. So a function means basically if we have A, this is our domain, this is our codomain, B, one point can map to a unique point of B, right? One point is allowed to map with a unique point of B. This F is unique. If we have some example that X is going to Fx, also F is going to some Fx dash. So this is another point of B. This is other point of B. Then is it a function?
No. No, ma'am.
Okay. So yeah, if we have that 2 points here, if we collect 2 points from the domain, suppose f and x and y. So yeah, is it allowed for x and y to go to the same point? Like f of y equals to f of x. Is it allowed? Mhm.
Yes, ma'am. Maybe this is allowed. Not sure.
Yeah, you're correct. This is allowed. But if this happens, then the function will not be 1, 1.
1-to-1.
Okay.
Yes, sir. Yes, ma'am. It won't be one, ma'am.
And this function will not be
That means every element X in the domain should have a unique pre-image, right?
unique image.
Yeah.
Not pre-image. Pre-image means
Unique.
here if we have some
Oh, yes.
point in
Unique
the domain,
image.
yes,
Unique image.
this point can have more than one pre-image, but every point here it have to be like it has a unique image. Okay,
Unique. Okay.
so this formally we can say every point of A has a unique image. So if a relation which satisfies this condition, then we will call that relation is a function, right?
Yes, ma'am.
And if it is 1 1 function means simply if we say if we take some x1 x2 from the domain, then x1 not equals to x2 if it implies that f of x1 not equals to f of x2, then we will say f is 1.
Is 1.
This is just a formal definition and you have some basic understanding. So,
Ma'am,
Yeah.
in the above diagram, could you please explain by the concept of pre-image? That is where I usually get confused while proving if a
Yeah.
particular relation is a function.
We'll definitely do it. So suppose this is the function here. Okay. So this is our domain. This is our domain A. This is our codomain B. Okay. Now, if we have some point X here, then image of F is this one, which is really this one, F of X. Okay. And this graph is basically X comma Fx. Okay. So if we have a point X in the domain, then this is the image for X. And if we have a point, suppose some Y in the codomain, then this is the pre-image. Okay. Some Y is. Okay. And this point, this particular point is Y dash comma Y. Better to let it X dash comma Y. Okay.
So pre-image is basically when we are talking about the codomain and we are relating it with the domain, right?
Yes.
Okay.
So is it clear? The concept of the image and pre-image. This is
Yes, ma'am. Yes.
for f of x and this is image for f. Okay.
Yes, ma'am.
Yes, ma'am.
So now suppose you have a graph. This is our suppose this is our A, this is our domain, and this is our B, this is codomain. Now suppose you have some graph, something like that. So can you say is it a function or not?
No, it is not.
Why?
Because vertical
not
line
pass the
test
vertical line
fails.
test.
Just 1%, please. Yes.
Because one in a function, one image can't have two pre-images.
Okay, right. So if we take some vertical line here, it will cut this function at 2 points, right?
Yes, ma'am.
So for x, this is fx, like this is fx. Again, this point will be fx, which is not possible, right? Because these 2
Yes,
points are
ma'am.
different. Now, if we just change our domain and codomain, we make this line as b and this line as a, then
Yes, ma'am.
Yeah, then it is valid.
It becomes a quadratic function.
will it be 1 or not?
No.
No, it won't be 1.
Why?
The horizontal line.
Same. If we draw this line, then for one function, we have 2 pre-images. So this is not 1. Okay, so you know the graphical representation. So yeah, suppose we have fx equals to mod x, where x belongs to the real number. So this is a function from the set of real number to domain. What will be the domain? Can you say? Anyone? Sorry, what will be the codomain?
0 to
Ma'am,
infinity.
0 to
All,
infinity.
all natural numbers.
0 to infinity.
Minus infinity to positive infinity.
0 to
Minus
All
infinity.
natural numbers.
positive infinity, and I will collect all the answer. Minus infinity to positive infinity. Second.
0 to infinity.
0 to infinity.
Okay. Third. Any other?
No, ma'am, the same thing. Positive integers. So yeah, 0 to
So
infinity.
this will be domain, this will be codomain.
0 to infinity. Ma'am.
Yeah.
Ma'am, mod x is
So
always
if I take,
positive. Mod x
yeah.
is always
So
positive.
if I
So
take these as codomain, will it be correct or not? I want to know your answer. If I take this as our codomain,
it's
No.
wrong, ma'am. Wrong, ma'am.
No, ma'am. No, ma'am.
why?
It's wrong.
Why wrong?
Because
Because it only gives the positive.
Please, just like try to think over it. Is it really wrong? If I take this as our codomain, not
No.
range.
It is right.
It is right.
It is right.
right?
It is right.
Because
Because
codomain
0,
contain
because
codomain contain n number of elements, no issues.
yes. This is subset of this, right?
yeah.
Yes,
So
ma'am.
if I am talking about range, this is a
This is the
range.
range. This is the range.
Yeah, it is the range.
Yes.
This can be codomain also, no problem. If you like take it as codomain, still we don't have any issue. But this is a range also, right? And if I take this as our codomain, then there is no issue, right? Am
Yes,
I
ma'am.
clear?
Yes.
Yes, ma'am.
Yes,
But
ma'am.
then, ma'am, if we write the function as R to R, then in that sense also 0 to infinity would lie in the codomain, right?
Can you say again?
If you write the function as R to R, that means we are considering the codomain as R. Then also 0 to infinity would lie in that as well, right?
Minus infinity to plus infinity is actually our set R, right?
Okay.
This is actually the real number. This is actually the real line. Minus infinity to plus infinity.
Yeah, got it.
It will be a function, but not one function. You want to say that?
Yes. If our codomain is this, yeah.
Okay.
So is it 1 or not?
No, it is.
No, it is not.
It is not.
Clearly it is not 1, because we can see the graph. This is one step, and clearly also we can see that f of 1 equals to f of minus 1, where 1 not equals to minus 3. For any negative and positive number, we can check it, right?
Yes.
So now I think the concept for function and a 1 function is clear to you, right?
Ma'am, can you please explain the horizontal test and vertical test one time?
Okay.
Actually, at what time we are test horizontal and when we will test vertical?
Better, I will say, yeah. Still, it is something like horizontal test and vertical test. But better you can understand the concept, okay? Because
Yeah.
we can change the domain and codomain also. That's what I was saying. If I make this our x-axis as a domain and this as our codomain, if we take this function, then this is a vertical line test, and it will fail the test, right? So here, if we take one point from our domain, from A, this is our domain, we are taking this point from the domain, then it will cut here at 2 points. So if we take the image, this is fx, this is also fx, right? But
Yes.
in the codomain, this point and this point, they are not same, right? These two are different points.
Yeah.
But
Yes,
what we know, a function can have only one image, right? The image in the image for any point in A is unique, right?
Yes.
Yes, ma'am.
So it will fail the criteria, right? Now suppose I make this as our domain
Okay,
and
we are
this
just
as our codomain. Then
reversing this.
yeah, yes.
Okay,
Suppose I'm just reversing it. This is our domain now and this is our codomain now.
then the fx
will
values are changing.
Yes.
Fx values are changed, and according to the x value is the same.
So then this points are from our domains points, and this is our point from a codomain. So here 2 points from domain we are taking. They have same pre-image, so no issue with that, right?
Yes.
So this is the concept. You should learn the concept. Okay.
Okay.
Is it clear to you? All of you are like convinced with this?
Yes, ma'am.
Yes, ma'am.
So yeah, if we take fx equals to x cube, what about this? It will be a function 1, 1.
This one, this is 1, 1 function.
1, 1 function.
1, 1 function. Because it's increasing to decreasing.
Yes. This is a monotonic function. Also, you know how to draw a graph for polynomials, right?
Yeah, ma'am.
So
Yes,
from
ma'am.
this also you can check this is our domain, this is our codomain, right? So from this also we can check with this graphical things. Okay. Okay. Now suppose you have f of f equals to some root x. Can you find the domain and codomain for this?
No. 0 to infinity, both.
Domain is 0 to infinity.
Okay.
Domain maybe
Codomain R.
Codomain
Codomain
0 to infinity.
0.
0 to infinity, right?
If it is
Square
real,
root,
then
because it's a square root, so no negatives are allowed. So
This is codomain, right?
ma'am, domain can be real number.
Ma'am, codomain can be real numbers, na? All.
No, ma'am, the domain can be real number, na?
Okay.
The value.
if domain is
codomain
positive, how you will
if
get a codomain negative? Because it's a square root, so there's no negative numbers will be there.
minus, if you take -1, it will become a complex number.
Yeah.
It's a complex number.
Okay. So if we take R as our domain, suppose we don't have any kind of restriction here. We are working on real line, no? So suppose you don't have any kind of real line restriction here. Suppose I take R as our domain, then what will be the codomain? What about the codomain?
Ma'am, that could be also, ma'am, R. That
it could be
ma'am,
also.
yes, ma'am, that could also be R. The range is
If I
from
take
0
minus
to
1
infinity.
here, if I take -1 here,
Complex number.
what
So
about
then it becomes complex
I
number.
Then it
complex number.
become complex number.
so what will be the
Not a
codomain
real
then?
number.
What will be the codomain then? What is the
Real
codomain?
numbers and complex numbers.
So real number is subset of complex number, right?
Yes,
Right? Convinced with
So
that?
real number.
So codomain, what will be the codomain?
Complex number.
Right?
Yes,
Yes.
it must be the
Codomain will be complex number,
0
right? If I take
0 to
R as
plus
domain,
infinity.
0 to plus infinity.
Yeah.
Minus infinity 0.
So if I take -1, when we are taking R as our domain, we can take -1 also, right? -1 has some image. Because if it is a function, then all the points from the codomain has some image necessarily, right?
Yes, ma'am.
Yeah. So -1 also has some image, right? This is
Yes,
I,
ma'am.
right?
Yes,
Iota.
ma'am. Yes, ma'am. Yes, ma'am.
Iota belongs
Yes,
to
ma'am.
complex number, which is not in real line, right?
Yes, ma'am.
So our codomain cannot be the real line. Okay,
Yes, ma'am.
Yes.
convinced? So what will be the codomain then?
Complex.
Yes, complex number. So yeah, sometimes the codomain, it is dependent on the domain, right? If I take 0, infinity as our domain, then R will be our codomain. Real line will be our codomain. But if I take real line as our domain, then complex number will be the codomain. Okay.
Yes.
Yes,
So
ma'am.
codomain is basically dependent on the domain and the function.
But ma'am, in this case, we are neglecting iota or not? If
I just said you for your better understanding.
okay.
So here we will not consider the complex number cases. Okay.
But
So we will
in this,
only see the real number cases. But in general, for this function, you can take real line also.
but
For
this,
this, the complex number will be the codomain.
okay, ma'am. But in this example, it's the codomain is dependent on the domain, depend on the codomain, na, ma'am.
The codomain is always dependent on the domain and the
Yes.
function.
Yes.
For any case, the codomain is always dependent on the domain and the function. Suppose we are taking fx equals to x squared. And if we take real line as our domain, then what will be the codomain?
Real line.
No, not real. It's a square. 0
Not
to
Real
necessarily.
line.
And you are making the same mistake. I'm talking about codomain. Codomain can be positive real line. It can be real line also. I'm
Yes.
not talking about range.
It
Yes,
can be
ma'am.
R, right?
R.
It's complex.
It can be anything. Like 0 infinity is the range, right? This is f of r, right?
Yes, ma'am. Yes.
So this is subset of real line. Real line is again subset of complex plane.
Range should be subset of codomain.
Domain. So we can take this as our codomain. We can take this as our codomain. Also, we can take this as our codomain. Right?
Yes.
okay,
Okay.
ma'am. Actually,
So if I
every
take
time we
this,
are thinking range, about the range.
Because you're
no,
getting confused with
I am talking
bijective,
about
injective.
codomain, not the range.
Because we had like a bijective, we were telling
Yes.
codomain and range is the same. I can recall from the other classes.
If we have a function which is for which the range and the codomain are same, then we will say the function is onto, like it is reversible then. Okay. If it
So,
is
ma'am,
one,
Yes, ma'am.
it will be reversible.
Ma'am, in the question root x, the second last question that we have done, for that, we said the domain would be R and the codomain should be 0 to infinity, right? Sorry, the domain is 0 to infinity and the codomain is also 0 to infinity, right?
Which question? Can you repeat?
Ma'am, the recent question that you have done just above that.
The function, what was the function?
Yeah, the root x one that we,
Okay.
yeah, this one. For this, the codomain will also be 0 to infinity, right?
It can be R also. 0 to infinity is subset of R, right?
Achha, okay. But the domain will be 0 to infinity.
Complex number.
If the domain is 0 to infinity, then the codomain will be this. If the domain is R, we can take domain is R also.
Achha,
But
okay.
here we will not consider the case because we are avoiding the complex number system here, right?
We are studying just the real number line. Got it. Okay.
Yes.
Thank you.
But also in general case, you can take R as domain for this function. And in this case, the complex number system will be the codomain. Okay.
Yes, ma'am. Got it. Thank you.
So, yeah, is it clear? Suppose we have this function, then we can take any of them as our codomain. Convinced?
Yes, ma'am.
But if it is about the range, what is the range?
0 to plus infinity.
So if I take this as a function, okay, let me first explain about onto function. So onto function means your range will be same as your codomain. Okay. When our range is same as our codomain, that means if we take any point, if we suppose we have a function f from a to b, if we take any point here, if it is guaranteed that there is a pre-image for this function, then we will say that this function is onto. Okay.
That means in B, all the point is matched with A in
All
any
the
house.
or for all the point, if we have a pre-image, then we will say that the function is onto. Okay.
Okay.
Yes, ma'am.
So C and the pre-image we will say f onto. Okay. So if we take f from R to R, x goes to x square. So is the function onto? So there is three questions. First of all, is it a function? So clearly you know it is a function. Is it 1, 1 or is it onto? So first of all, let's talk about 1, 1. Is it 1, 1?
No. No. Not 1, 1.
Right?
Because for 2 and -2, the value remains same, ma'am.
Yes, for 2 and -2, the value will be same. Here this function is not given. Is it? Is the function onto? We are taking R.
No, ma'am. No, ma'am.
Okay.
This is on to.
And because 3, 5, these are not in the range.
Not onto as well.
Did ma'am just get disconnected?
Yes.
And there is some network issue.
Yes, bro. Hello? What are you saying?
Sorry, I got disconnected because of some network issue. So yeah, give me just 2 minutes. We will start again.
Okay, ma'am.
Okay, ma'am.
So yeah, we're talking about onto function, right? So
Yes,
yeah. So if I take f
ma'am.
from
Screen is not visible.
yeah,
Actually, screen
it
is not
will
shared.
take yeah. I know it will take some time. Then but up to that we can like discuss it. So
Okay, ma'am.
yeah, you can write it on your pen paper. So yeah, if I have f from R to R, fx equals to x square, then it is onto or not? It was our question, right?
Yes, ma'am.
Yeah. So is it onto?
No, ma'am.
No, no.
Right?
the all the values.
Because 2, 3, 5 doesn't have any images.
2, 3, 5. Why? So what did you say? Just wait for some minute. I can't share my screen right now. Just wait. Hello. Yeah.
Yes,
Hello,
ma'am.
Mahesh. Actually, I got disconnected. Now I can share my screen again. Yeah, am I audible?
Yes, ma'am, you are audible.
Ma'am, you are audible.
Yes, ma'am, you are.
Okay, 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 okay. Actually, I got disconnected, so I can't share my screen now. So just let me some minute. Always this type of problem happens with the iPad. I don't know why. Yeah, so are you now able to see my screen?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So yeah, we're talking about the one onto function. Okay. So we take f from R to R, x goes to x square. So yeah, is it onto or not? Is it onto?
Yes, ma'am.
If we have y equals to x square, we can draw the graph, right? from the graph, from the graph also you can say, is it onto or not?
And ma'am, it depends on codomain, I think.
Code
Codomain
is
is
given as
It is
R.
onto.
codomain and R.
Then this is not onto.
This is not onto.
Why?
This is onto, ma'am.
This is onto.
It's
Yes,
onto,
it's
ma'am.
onto because -1 + 1 same image.
It is not onto because if you pass a horizontal line, it will have 2 points on the curve.
Pre-image should be unique or not?
No.
So, okay. Let
is
us
not
review the
Ma'am,
definition. Let us review the definition. Okay, then I will listen all of you. Let us review the definition. If all the points of B has a pre-image, then we will say that F is onto.
It's
Not necessarily unique, nothing, but we know we.
Every element in B should be related.
Yes. So, yeah, what about this? Someone was saying for -1 and +1, we have the same images. So, yeah, can you really done any kind of conclusion from this?
Yes,
We
ma'am.
want to know.
This is
Yes.
onto. If this is onto, that means
Right.
from this graph, if we draw from any point the vertical line to the x-axis, there is maybe an image.
Okay. But what about this point? Real line means this whole line, right?
No, vertical line, ma'am. Ma'am, vertical line. From any point of this graph, if we draw a vertical line to the x-axis, for
then
all
it
the
will have an image, right?
yes.
So I wanted to know whether the function is onto or not.
Onto, ma'am.
It is onto function.
No, not onto, ma'am. Because codomain is R.
Not onto function. It's the
0
onto
to
function.
-infinity is not related.
Yes. So
Negative.
whoever says it is onto, I just yeah.
We will
I
have
just want
every pre-image will be available for
you
every.
can look at the definition for a onto function that for every point in the codomain, we will have some p-image. So if we take some point here, is there any p-image for this?
No, ma'am.
But then, ma'am, don't we consider the codomain and the range should be equal?
Yes. If a function is onto, then the codomain and the range should be equal. But
Should
we
be
can
equal.
see here the codomain is 0, infinity, right? From 0 to infinity. This is our codomain because our function is on the positive y-axis, right? Our function is on the positive y-axis, right?
That is
There
all
is
right.
nothing in the there is nothing in the negative side. What about the negative side? Real line means we have the positive and negative both the sides, right?
Yes, ma'am.
But then
Yeah.
I just want to ask you something. When we are writing function from R to R, doesn't that mean that when we are writing towards R, that means that should be the codomain?
Yes, this is the codomain. No
Okay, so
problem
that
with that. This is the codomain. But what is the range here?
0 to
It
infinity.
represents the positive while the
0 to infinity.
codomain, yeah.
This is the range, right?
Yes, this
Yes.
is the range. Yes.
Clearly, this is not equals to real line.
Yes,
Yes.
Yes, ma'am.
So this function is not onto, right?
Yes, ma'am.
Yes, ma'am.
Yes.
Simple thing is, if a function is onto, then the range will be same to the codomain. Here, we can easily see that the range is not similar to the codomain. So the function is not onto, okay?
Yeah, okay.
And from the graph also you can see, if I draw this, it will be something like that. And the whole function, this is our function, right? This is our function. The whole function is in the positive y-axis. So if we take any point here, can take any horizontal line, it will never cut the graph, right? It will never cut the
No
graph, right?
pre-image.
Yes,
Yeah.
ma'am. Yes.
So for this point here, there is no pre-image. Okay?
Okay.
When
Now
I
got
am
it.
taking some point, the domain, then we will say this is the pre-image. If I take some point from the codomain, then we will say this is the image, pre-image, okay?
Yes, ma'am.
Yeah, got it. So definition that you wrote above, and by what we mean is, by that we mean is a range should be equal to the codomain, right?
Yes, yes.
Yeah.
Because
Okay.
in this definition, we are saying if all the points of B, that means our codomain, has a pre-image. Pre-image means there is some x such that fx equals to that y. Suppose we are taking some y from our B. So this y has a pre-image. That means there exists some x in A such that f of x equals to y. Right? This
Yes.
is the mathematical expression, right?
Yes, ma'am.
That
Got
means
it.
for any point we have a pre-image x. So it will imply that the range shift equals to B, right?
Yes, ma'am.
We can also prove that. That means we already know the range is a subset of B, right?
Yes, ma'am.
We want to prove that the range is equals to B. We want to prove this, right?
Yes, for onto yes.
Yes. So if that means it is enough to show B is subset of R, right? The codomain is subset of range. If we can show that, then it is enough to prove this line, right?
Yes,
Do you know
Yes,
about
ma'am.
it? You know
Yes,
this
ma'am.
method, right? If we want to show that the set are equal, then A is subset of B and B is subset of A, right?
Yes, ma'am.
Yeah. So for that, we
yes, ma'am.
already have R is subset of B. So it is enough to show that B is subset of R, right?
Yes, ma'am.
Yeah.
Yes, got it.
So if we take any y from B, then there exists, if the function is onto, then there exists x in A such that f of x equals to y, right? From this definition.
Yes, ma'am.
Yeah, from this definition, right?
Yes, ma'am. Got it. Thank you.
Yeah. So that means this y will be in the range. So this is the proof. You can analyze anything with some 2 or 3 steps. Okay. So again, let fx equals to x cube from
Ma'am,
R
I
to
have ma'am, I have doubt in previous question.
yes.
Ma'am, what happen if we take a codomain 0 to infinity, then
Okay.
when
So
we put the value x is equal to
0
1,
close or open.
ma'am, close.
If we take
Ma'am,
open,
when
suppose for example, we are taking fx equals to x square from R
yes,
to
ma'am.
0 infinity. Is it a function? Can you say about it? Is it a function? Let me write it again. I am taking
Yes,
f
ma'am.
from R to 0 infinity. X goes to x square. Is it a function?
No, ma'am.
Why?
Because for 0 there is no value.
Yes. For 0, there is no image. We will say image, okay? So this is not a function. Yeah. Now you can tell what is your doubt.
Ma'am, I have doubt that if we just take a positive real number, then in codomain, then if we put the value x, then we get a square 1. Then we put
Which is
2,
again a
then we get
positive real
4.
number.
Then we get 4. Ma'am, but what about 3? It is also not in the
Root
range.
3. Root 3, if we take root 3 and then square it, it will be 3, right?
Okay, ma'am.
We
Okay,
are
ma'am.
taking
Okay, ma'am.
real number here. So root 3 is a irrational number, right?
Yes, ma'am.
It's again in the set of real number. Mhm.
Okay, ma'am. Yes, ma'am. Yes, ma'am.
Yeah. So, yeah. Is it now clear, this example?
Yes, ma'am. Yes, ma'am.
So, for this example, we can summarize this. We are taking f of equals to x square. If I domain, codomain and range.
Why
Sorry,
x cube is not a function?
Yes.
I have a doubt regarding the x cube. F of x is equal to x cube. Why it is not a function? No?
No.
It
I
is a function.
was talking about this. This x goes to x square, and
Yes,
here
ma'am.
I took R as our domain and 0 infinity as our codomain. So is it a
Okay.
function? Not, no?
Yes,
Because
yes.
for
Okay, okay.
0, we don't have any image. This will not
Okay,
be a
okay,
function.
okay, got it, got it.
Yeah. For this function, if I take R and here, if I take this, then it will not be a function. If I take R, again R, then it will be a function, but not onto. If I take R as our domain and 0 infinity as our codomain, then it will be onto function, right? Now suppose I take this as our domain and this as our codomain. Then is it 1, 1? Clearly this is onto because this is our domain. But is it 1, 1?
No,
No, it
ma'am.
won't be 1, 1.
Why?
For minus and plus, there would be the same value. Like minus
But
5
this
would
is
give 25 and
our
plus 5
domain
will
is
also give.
no.
Domain is not
Our domain is
minus.
0 infinity here. You have to
Then 1,
check.
1.
Yeah. So whether the function can be 1, 1 onto, even it can be a not function, dependent on the domain and codomain. So you have to be very conscious about the domain and codomain always. Okay. So here are 4 cases I discussed about it. So you have to be conscious about it all the time. Okay. All the cases are clear to you, right?
And the last one is not clear. Why is it 1, 1?
Because if it is not 1, 1, what is your example?
I mean, if you
Minus
take
1
minus
not
1
equal to
and
1.
1, yeah.
Minus 1 is not in domain, ma'am.
But
In this
yeah,
case.
is minus
Okay,
1
got
in
it,
this
got it, got
domain?
it. I got it, got it. Yeah, got it. I understood
So
what you
it
were
is,
trying to say, yeah.
yeah. So it is clear right now for all
Yes,
of you, right?
But ma'am, if
Mhm.
in the codomain
Yes,
the
clear,
close
ma'am, clear.
though the close bracket, if we get a single bracket, then this is not a function, na?
Can
In
you
the last
in the
example.
code? Yeah. In this case.
Yeah.
In
Yes.
this case,
It's
yeah.
not a function.
Then it will not be a function. Yes.
Okay.
Because 0 have no image. And if it is a function, then every point from the domain should have the image, which is unique. Okay.
Yes, ma'am.
Ma'am, as from 0 to infinity, there are no negative values. So it is 1, 1 function.
Yes. For this
Okay.
case.
Yeah,
So
okay,
all
okay.
the 4 cases are now clear to all of you, right? These are the 4 cases. Clear
Yes,
to all of you, right?
Yes, ma'am.
Yeah. So if we take this function, so yeah, whether it is 1, 1 onto first check with 1, 1. Is it 1, 1? You already know it is 1, 1, right?
Yes, sir.
Yes, ma'am.
Yeah.
This is 1, 1.
So whether it is onto or not. Is it onto?
It's
Yes.
onto, ma'am. It's onto.
This is onto. Because clearly from the graph we can verify. If we take any point, we will find some pre-image, right? We will definitely find some pre-image.
Yes.
So this function is onto. Okay. I
So,
think
ma'am,
now, yes.
I just want to know. So every even polynomial is not onto, and the odd polynomial all are onto.
Yes. Yes. Yeah.
It will depend,
Because
no, madam? It will depend whether it's
no,
what's a domain, codomain, because you recently you told, no,
it's
onto or
actually depends. Yeah, it's actually depends on the domain and codomain. But yeah, naturally, if we have something even like some even number of roots, then it will like work like that. And if we have some odd number of roots, then
Actually,
it will
in the case of odd number of polynomials, there is an minus infinity to plus infinity, na? The
Yeah, but a polynomial will also have other roots which might cause a bounce or something, which might not be able to confirm that if it is one to one.
if you have something like that, a single root or else with even degree, something like that, then you can say it will not be 1 1 dependent on the domain and codomain. If we restrict the codomain, then it will be the onto. If we take all the points from it may not be onto. And if we take something odd with some like in this manner, x minus some a into with some even with some odd power, then naturally it will be onto function, because we will have some graph like that. But suppose you have uh, such a function x into x minus 1 square, then the degree is 3, right? Then it is
Yes,
a
ma'am.
odd degree function, right?
Yes, ma'am. But this is x
But it
minus 1
passes.
whole square is bounced on the plus 1 point. Point 1.
Yeah, then it will be something like that, right?
Bounce, yes, yes.
But in that case, it will be not, it will not be 1 1, right?
Yes, ma'am.
Yes, ma'am.
So about 1 1, we cannot conclude anything from this.
But it's onto, na, ma'am.
No, this is also not the case. Suppose you have something like that, some function like that. Like this. Okay.
Okay. Then the
So
y
for this,
minus value is not
uh,
so.
some with some tilde here, okay? Then for this we'll have some odd degree, here 1 and here even. So overall degree will be odd, right? Right? Overall degree will be odd.
Yes, ma'am.
I'm taking something
Overall
like
even, no.
No, it won't be.
Overall
It
even.
will be even because it's parabolic path.
okay. There is no issue. We can take something like that here. Then it will be odd,
Yeah,
right?
now it's odd.
Yes.
Yes, now it's odd.
We again cut it. Yes. Okay, then it will be even. Yes, from this we have odd. From this we have even. You can simply take some function better. Then it is yeah.
Odd one.
So yeah, then it is odd. But yeah, in this case also it is on to.
The maximum odd polynomial is behave like onto now.
Yes. Yeah. So yeah, from the graph we can analyze
because the
something like
end
that. Yeah.
because the end behavior is
End
opposite.
behavior will be different. Yes.
Opposite.
Mhm.
So
For
every point there
x
is
tends to infinity, f of x will be tends to infinity, and x tends to
minus infinity to
minus infinity, x of x will be minus infinity. Yes. So it will be always something like that. So yeah, it will
all
like
time on
cover the whole minus infinity line. Yes. Yeah. Yes, you are correct. Yeah, you are correct.
Yeah.
So yeah, if it is odd degree polynomial, then it will be onto, but we cannot comment anything about the 1.
Yes, ma'am.
So it can be injective, it cannot be injective also,
Yeah.
but yeah, it will be onto.
Okay.
But if it is a either polynomial, then it will not be onto. Yeah. Okay. So up to now we covered what is function, what is 1 function, and what is onto function. So if we have a function which is both 1 and onto, then we will say that the function is bijective. Okay. And if a function is bijective, then we will say this is invertible or reversible. Okay.
Yes, ma'am.
So if we, okay. So if we have a function from A to B, definition, then this is said to be invertible or reversible if there exists F inverse from B to A such that F inverse F of X equals to F inverse of X equals to identity function of X. Okay, you know what the identity function is, right? This is actually, yeah. So if we have something like that, then we will say that the function is invertible, and this F inverse is said to be the inverse of F. Okay. And this is simply simple notation. We can denote it as this. And this is called position of function. Okay.
Yes, ma'am.
So if you find something like that, that means like if we find F compose G of X, that means F of G of X. Okay. This is composition of function. So in that case, if we have a function F from some A to B and G from some C to D, suppose, then F compose G, this what will be the domain? What will be the domain for F compose G?
The intersection of A and C.
Intersection of A and C. Why?
Yes.
Why?
Ma'am, maybe
Union, no?
A
Union
and
of
C.
both. Range
It
could
can be
be
in any
intersection,
section.
but this could be
Okay,
union.
so we have so many answers. Let me write down it. I will forgot me. Okay, so we have C union A. We have C intersection A. Any other answers?
Only C, ma'am.
Only C. So these three answers we have. Okay, so if we take something like that, if it is a function, then what we know that every point from the domain should have some image, right? So if we take anything from C, if we take any x belongs to C, then they if of g of x always exists, right? F compose g of x means f of g of x. So this is our first concern, right?
Yes, ma'am.
G of x is our first concern. So if we take anything from C, then f of g is defined, right? This is then defined, right?
Yes, ma'am.
Yes, ma'am.
C can be our choice. If we take a C intersection A, then C intersection A is subset of C, right?
Yes, ma'am.
So we have a bigger option. So why should we, then why we will choose some smaller option? No,
Yes,
we
ma'am.
can make it as domain, but we have a bigger option, right? We have the largest
Yes, ma'am.
set here.
Yes.
And C is subset of C union A. But suppose we take some points from C union A. It may be from C, it may be can be from A also, right? So suppose I took some x from A. So is there any guarantee that g of x will exist?
No, ma'am.
No, ma'am, no.
So this is clearly wrong option, right?
Yes, ma'am.
Okay. So our correct option is C. So our codomain will be, our domain will be C. Clear?
Yes, ma'am.
Yes, ma'am.
So what is the midpoint? It started from C. Here this is something and here it will be something. This is our domain. This is our domain. This is our codomain, right? So, okay. Suppose we took C as a function, as a domain, and there is some x in C, then such that this is also wrong actually. I wrote wrong. This is also wrong. So there is some reason behind it. Suppose I took some x from the C such that g of x, this doesn't belongs to A. Then is it possible
Yes,
to
ma'am.
take any kind of x from C?
Yes, ma'am.
Is it possible? So then we can take the whole C for all the cases, right?
Yes, ma'am. Then,
He
ma'am,
explained it to some
when
example
the
so that will
range
be
is
easier.
D intersection
Yeah,
A.
I will give example.
Yes, ma'am.
Yeah, I will definitely give example. Yeah. So our domain is basically C, x belongs to C such that g of x belongs to A, right? Because see, if g of x doesn't belongs to A, then is there any guarantee that f of g of x will be defined? We need the whole function to be defined, right?
Yes, ma'am.
So there is no, if gx is not in the set A, then there is no guarantee that f of g of x is defined, right?
Yes, ma'am.
So we need this condition for domain that x belongs to C such that g of x belongs to A, right?
Ma'am, if
Clear?
there
Why
is,
I need this condition?
ma'am, if there is no intersection between A and D, then function is defined.
If there is no intersection between A and D.
Yes, ma'am.
then also the function is defined. No problem.
Okay, ma'am.
We don't
Ma'am,
have
because
any issue with the AMD.
ma'am, because I ask when we put any value in from C, then output comes to D, and when no intersection from A and D, then all
Okay,
output
so
from
this is
A,
a
all
mistake.
output from D, then we can't get any input for the FX.
Okay, so this is a case. Okay, we will try to construct some example based on this case. Okay, then it will be more
Okay, ma'am.
clear. Yeah.
Okay,
So,
ma'am.
yeah, we will try to construct some example. This I
Okay.
noted down. So now this why this condition is needed? It is clear to you, right?
Yes, ma'am.
If gx is not in A, then there is no guarantee that f of g of x will be defined. So we need the
Yes,
condition
ma'am.
x belongs to C such that g of x will be in A.
Yes, ma'am.
Okay. So suppose A intersection D is 5.
Yes, ma'am.
Okay. And g of x belongs to range of G, right? Which is subset of D.
Yes, ma'am.
So if A intersection D is 5, is it possible that Gx belongs to A?
No, ma'am.
No, ma'am.
So this case is not possible, right?
Yes, ma'am.
If D intersection A is 5, then we cannot define the composition of function. Right?
Yes, ma'am.
So what
Yes,
will be
ma'am.
the
Yes, ma'am.
codomain? It is clearly the codomain of F, right? Which is B. Right?
Mm.
Because we are applying F at the last. Suppose this is some D dash. So our F composition G will be D dash to B, where B is codomain of F and G
Yes,
is
ma'am.
this belongs to C such that G of X is in A. So yeah, is it clear?
Yes, ma'am.
Yeah. So there is one point. If we mean F inverse, that is definitely not equals to 1 by F. You already know this one, right? These two things are different. Okay. For function, because for a number we can do this, but for a function this is not same. These two things are different, because if we take f at x cube, and then what will be the f inverse? It will be cube root of x, right? Right?
Yes,
Yes.
ma'am.
We can calculate this also. Suppose we don't know what is our f inverse. We don't know, suppose. So what we know, f compose f inverse of x equals to x, right? That we know. Also we know that f inverse compose f of x equals to x. This too we know, right? So if f inverse is the inverse of x, then it have to satisfy these two property. So we don't know what is f inverse, right? So from this we get f of f inverse x, this is equals to x. And what is fx? If we take this as x, then it will be f inverse x whole cube equals to x, right? Then it will be f inverse x equals to cube root of x. Fine?
Yes,
Fine?
ma'am.
Yes.
So since we already know this function is a bijective function, so we have the guarantee that inverse will always exist. Okay. So for
Yes, ma'am.
the inverse, this is your first criteria. You have to check first whether the function is bijective or not. Now, if you find that the function is bijective, then you can calculate the inverse with these two conditions. So this is our F inverse. And 1 by F will be 1 by X whole cube. Right? Which is X to the power minus 3. Right? And this means X to the power 1 by 3. So clearly they are not same.
Yes.
Clearly they are not same, right? So these two
Yes.
things are not same for the function. So for composition of function, F is from A to B. This is a summary. G is from C to D. For composition, F compose G from D dash to B. And here a condition we have that A intersection D will not be 5. And this condition is really very important. Otherwise, the composition will not be defined. Okay. Okay. Clear now? Up to this is clear to you, I think.
Yes, ma'am.
So we can now look at some examples. Suppose I take F from real number to real number such that X goes to X squared and G from infinity to suppose I take some X goes to X plus 1. So let us take or else I can take it as real number. So suppose we have this two function, F equals to this, G equals to this. So what will be F compose G? What is the codomain? What is the domain? And what is the function? One by one. So what will be the domain first?
0 to infinity.
So
R.
domain is 0 to infinity. Someone said R. Is it R? If I take something minus, some minus 1. Here it is defined, no problem. Okay, suppose I take this as a column. So now is it defined? If I take some minus 1 from R, minus 1 belongs to R, right? Then G of minus 1 will be 0, right? Which is not in the codomain of G. Right?
Okay.
It's not defined then. So the domain, here we took that D dash as our domain. We see that X in C such that Gx belongs to A. So this is always subset of C, right? Domain of G. This is always subset of C, right? So here for G we have the domain 0 infinity. So this will be the domain, right?
Can you explain again?
Okay, so yeah, what is the codomain? And also say what is the range? First, yeah, what is the codomain? Codomain of D, right? Real line, right?
Codomain is R.
Yes. And what is the range?
Range 0 to
1 to
plus
infinity.
infinity.
1 to.
0 to infinity. Any another option?
Ma'am, 5.
Mhm.
There is no value in range.
There is no value in range. No value in range. Is that what you mean? Okay. So yeah,
1
as
to infinity.
earlier we have already
Why
seen
not 1
that
to infinity?
the range
Why range?
1 to
Because
infinity.
1 to infinity, because it's always be positive.
This is one. Okay. So yeah, okay. Let's now calculate the range. Okay. So the function is compose G. We can calculate F compose G, right? What we know, the range is dependent on the codomain and the function, right? So here our function is F compose G and our codomain is 0 infinity. Now we can calculate the function. This is F of G of X, right? And what is our G of X?
X
G
plus
of X
1.
is, yeah. So it will be X plus 1, right? What is F of X? X square. That means it will be X plus 1
Plus
square.
1 square.
Then it is whatever it is. So what will be the range then? We have
1 to infinity.
okay, 1 to infinity. Yeah, this is correct. Because if we put 0, this is the lowest value. Then F compose G of 0 will be 0 plus 1 square, which is 1. And if x tends to infinity, then F compose G of x tends to infinity. Right? Right?
Yes, ma'am.
Yeah. So this became our range, not this, not this. Okay? Clear? Clear?
The range is
Yes,
clear,
ma'am.
but
Yes.
the domain have some confusion.
Okay. So why are you confused with the domain? Here, what we know from this line. The domain of this function is this. X belongs to C such that G of X belongs to A, right? So first of all, we have it will be subset of C and our C is 0 infinity, right? Now, if we take any any non-negative real number, then the squared value, this will be in real number, right? And this is our A.
Yes, ma'am.
So this satisfy the condition.
Yes.
So this can be our domain, right?
Hmm. Yes.
Now is there still any confusion left?
Ma'am, but why not 0 in this case?
We're taking 0, no?
When we say x square belongs to R, we are considering 0 for the value of x square?
Sure. Why not? 0. Then 0 square will be again 0, right? This is belongs to R. So we are taking the closed interval 0 infinity.
Okay, so this is the domain for the composition FOG.
Yes.
Okay, ma'am.
Yeah. This is the domain. And this is the codomain. 1 infinity. This is the codomain. Sorry, this is the range. Sorry. This is the range. And this can be a codomain. Also, the whole real line can be a codomain. 0 infinity also a codomain.
Ma'am, for range, we say that the range are those values which the function can take.
Yes.
Ma'am, but when we say the composition FOG,
That
isn't
means
it?
our new function became F compose G.
Yes, ma'am. So, why are we not able to take 1? I'm getting confused over there.
We're taking 1. This is closed interval 1 infinity. We're taking 1.
Uh, Ma'am, when we say that our range starts from 1 and goes up to infinity, my doubt is why not anything less than 1? Why I'm not able to get that exactly.
Okay. So see, if I take something less than 1, suppose half. Suppose I took half. Okay. So is there any point belongs to this set, 0 infinity, such that f compose g equals to half? Is it possible?
Oh, ma'am, okay, ma'am, it's
That
possible
way?
only when x is minus half.
Yeah. It's possible when x is
Not possible, ma'am. Actually, square value. Sorry, ma'am. My
so
mistake.
x plus 1 will be 1 by 2.
Yeah,
Then
my mistake.
x will be minus 1 plus minus 1 by root 2, right?
Yes.
But this doesn't in our domain, right?
It's not real.
It doesn't belongs to in the domain, right?
Yes, ma'am.
This is real number, but this is not positive real number. This is a negative real number, right?
Ma'am, over here, when you say the domain, then you are talking about domain of the composition and not x.
Yes. Domain of the composition. And for the domain of the composition, we need this condition. Okay.
Yes, ma'am.
Yeah. So, yeah, is it now clear?
Yes, ma'am.
We can work with some other examples. Suppose
Ma'am, so if it was x minus 2 square, then would it be possible?
Okay. So f from R to R. So, okay, you can now give some example. We will work on that. Okay. So you say x goes to x minus 2 square, right? That is what you said, right?
No. X minus 0.5 or something. Means a value is bigger than 1 by root 2. A value is bigger than 1 by root 2.
So here we take x minus 0.5 square.
1 by 2. Write it 1 by 2.
That is what you mean, right?
Yes.
X minus, right? And G, what is G? Domain, codomain, and the value. All, what is G? Same as
G is x
this
minus
value.
1 by 2. Yeah. And F is x square.
If we took as this, you want to take this as
F is
G,
x
right?
square and G is x minus half. 1 by 2.
Okay. So we take this and G from R to R. You are taking, suppose R to R, x goes to x minus half square.
Minus 1 by 2. Not square.
Okay. So you don't need the square. Okay. So yeah, what do you want to know? So okay. So
If we
first
take
talk
f
about
of
the
g of it, then
domain. What will be the domain then?
any real number.
So domain is R, right? And what is the codomain? It is again R because we are taking
Again
the
real number.
codomain of F. Yeah. This is also right. So what is the function? What will be F compose Gx? This is F of Gx, right? That means F of x minus half, right? That means x minus half square, right?
Yeah.
So what will be the range?
0 to infinity.
My 1/4 to infinity.
0 to infinity. Someone said 1/4 to infinity.
Oh, close.
Okay. So any other option?
Ma'am, we can get the lowest value as 0. That's why I said 0 to infinity.
Yes. That is correct only. That
Pure
is
infinity
wrong
is right. Yeah,
because
so it's
half
zero.
is in
Yeah,
the
half
domain.
also part of it.
Yeah. So if we put half here, it will be
Yeah.
0. So this is our range then. Fine.
Because domain itself is R. Yeah.
Yes. So fine.
Yes, ma'am.
We can take some other example. Suppose if this from 0, 1 to some real number, let us assume it's real number. So x
Ma'am,
goes
please
to
take some example in which there is division by x, ma'am, or x square.
division by x square. Okay. I took this one. Okay. And suppose g from R to R, x goes to x to the power 5. Then discuss about same things. What is the domain? What is the codomain? What is the function? And what is the range? So what is the domain?
R minus 0.
Real number. That would be range. That would be
Domain should
Let
be
us first
R
talk
minus
about
0. Yes, ma'am.
R minus 0. Any other answer? Any other answer for the domain? So yeah, everyone is convinced with that, right? R minus 0 is the domain. Because what is our primary concern here? To check that every point from the domain should have some image. And here we have this kind of factor. So if we exclude the point 0 from the real line, then the function will be defined, right? Except 0,
Yes,
any real number, for any real number, the function will be defined, right? So this is our domain. This is correct. What is the codomain?
The entire real line.
The entire real line. So okay, codomain can be the entire real line because the here we are taking F compose G, and here R is the codomain of G. F. So yeah, what is the function? Of x to the power 5, which is 1 by x to the power 5, right?
x power minus 5.
Right? Yeah. So what is the range now? This is our domain. We got our domain. So what is the range?
Any real number.
Domain.
Any real number. You are saying that R is the
Except 0.
Yes. Because infinity is not a defined number, right? 1 by infinity, we assume that this is equals to 0, but this is not a defined number, right? So when x tends to infinity, the function f compose g, this will tends to 0, but it is not exactly 0 because we cannot put x equals to infinity here, right? Right?
Yes, ma'am.
So I think this is now clear to you. Any confusion?
Ma'am, once you explain, it's clear. But once there is a question in the exam, I always tend to make mistake.
Okay, so do you have any example? We can discuss here.
Ma'am, not right now, ma'am. If there will be any, I'll just share it on the, the group.
Yeah. Okay, then we can discuss about it. So I think.
Ma'am.
Uh-huh.
please tell me about codomain? I confused.
Okay. So codomain is basically a superset of range. Once you got your range, this is r minus 0. So this codomain can be this. This codomain can be r. This codomain can be complex number. Anything which is a superset of this range. Okay.
Yes. Yes.
If you once found your range, then any superset or the range itself can be the codomain. But we cannot consider any kind of subset of the range as our codomain. Okay.
Okay, ma'am.
So if in a particular case our range is equals to our codomain, then the function will be 1, 2. Okay.
Okay, ma'am.
So these are some concept. So we got 1 function, onto function, both are bijective. We got inverse of a function, and we got composition of function. Right? So do you have any kind of confusion with these concepts? No, right? Then we can discuss about exponential function. In short, we will write exp. In short, we will write. So if we have some function like that, a to the power x, where this x is greater than 0 and this ax is belongs to the real line, then we will say this is an exponential function based at a. This a is said to be the base, and this is exponent. Okay. This is the definition for exponential function. So we cannot take anything from anything less than 0, because otherwise this will be some complex number. So here we are considering just the real numbers. So in that case, we will consider our a as positive. Okay. Clear? Again, if we take a equals to 1, then a power x will be again 1. So there is no change here. If we take a equals to 0 and x belongs to r, so x can be 0 also, right? Then we will get this term. This is not defined. This is not defined. This is that undefined term. We will discuss about this kind of undefined term later on. Okay. So this is basically exponential function, and the base is a. So if we have a equals to e, then our function will be e power x. Sometimes we can also express it as exponential of x, and this is said to be this called natural exponential function. And for simplicity, sometimes we call it just simply exponential function. And if we use some other base, then we will mention based at a, based on 2, something like that. Okay. So this is our exponential function. We can draw the graph also. If we suppose take a equals to 2, then we will have something like that. So we can draw the graph for x power 2, right? If we have f of x equals to 2 power x, simply put x equals to 0 here, then f of x will be 1. Simply put x equals to 1, then f of x will be 2, right? So this is our 1, suppose this is our 1, 2, 1, 2. And when x tends to infinity, f of x tends to infinity. When x tends to minus infinity, f of x tends to 0, right? 0, right?
Yes, 0.
Yes, ma'am.
So we can draw the graph. This 0, 1 point means this point will lie in our graph, and the point 1 and 2. 1 and 2 means this point, right? So we can draw the graph like that. So when x tends to minus infinity, our f of x will be tending to 0, right? And when x tends to positive infinity, f of x will be tending to infinity. So is it now clear?
Yes, ma'am.
Yes.
Okay. So what I think these are the concepts which covered throughout the week 5. So I think there was nothing out of this, right?
Yes, ma'am.
Except this thing, I think there were nothing. So yeah, these are all. So now if you have any doubt related to this thing, you can ask it.
Hello, ma'am.
Yeah.
Ma'am, could you please take any example where in the exponential function there is a constant term in addition or in subtraction with it?
Okay, sure. So f of x equals to, suppose this we can take, right? So yeah, what we want to do? You want to draw the curve or what? Want to draw the curve, right? So we can check from this behavior when x equals to 0, if x equals to 3 plus 2 power 0, that means 4, right? When x equals to 1, if x equals to 3 plus 2, which is 5. When x tends to infinity, f of x tends to infinity. When x tends to minus infinity, f of x tends to 3. Right?
Ma'am, could you please explain this thing? When x tends to minus infinity, f of x
So if
tends
x
to
tends
3.
to minus infinity, then we have something like that. Limit x tends to minus infinity, 3 plus 2 to the power x, right?
Yes.
There is no term x in the first term. So this is same to as 3 plus limit x tends to minus infinity, 2 power x, right? And this is 0, we know, right?
But it tends to 0, no, ma'am?
Yeah. But for limit, we put the value directly because this is the value for the limit. It will equals to 2. Because we are taking the value limit. We are taking the limit. For limit, in that case, we just simply put the value. It will actually tends to 3, but we are taking the limit here, no? That's why we are writing this equals to 3.
Okay.
And here we are writing this in that manner. When x tends to infinity, f of x tends to 3. And here we are taking the limit here. That's why it is equals to 3. Okay.
Okay.
So from here we can draw the graph. This is 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this point we have 0, 4. That means 0, 4. This point and 1, 5. That means this point, right? This 2 point we have, right? And this is y equals to 3 line, right? So the function will be something like that. So when x tends to infinity, this tending to infinity. When x tends to 0, minus infinity, then the function is tending to 3. Correct?
Basically, ma'am, the function is shifted by the constant.
Yes. Simply, we are shifting the function with the constant, right? This is x plus our previous, just denoting it with f dash x. We are just shifting. We're just scaling this function. So yeah, is it fine now?
Yes, ma'am. Ma'am, then what will be happen when constant is in minus term, negative
So
term?
it will be again same, like so if we have some f dash x, then we will shift this at minus 3. So this will be something like that. Okay.
It will
We're just shifting this point from here to here and here to here.
Ma'am, in that case, it will cut the x-axis, right?
Yes.
So it will have
So if
roots
we
then.
have, see, if we have f of x equals to minus 3 plus f plus, 2 power x, then we can see that it will cut the x-axis. That means there will be some value for which this is 0, right? That means 2 power x equals to 3. From this, we can find the value of 2, right? X, right? We can take log best at 2 and then we can do that, right?
So in that case, the function will have root, real root.
Yes. This is the root.
Okay.
Yes.
Ma'am. Okay.
In
Thank you,
that
ma'am.
case, the function will have real root. Yeah. So yeah. Any other confusion? Any other doubts related to this?
No, ma'am.
Okay.
Ma'am, I had a doubt in a activity question.
Okay.
Ma'am, activity question 5.5, question number 1.
Okay. So is it related to this concept?
Yes, ma'am.
Okay. So yeah, you can share the screenshot in the chat box.
Yeah, ma'am.
You shared it?
Yes, ma'am.
Yeah. Okay. So okay, the formula is already given, right?
Yes, ma'am.
Formula is already given, which is a equals to 1 plus r n, where r is increase rate per year. Okay. N is the number of year. This is here. And S is value of one share.
1,000. So A is also given.
What is A? Is the present value. So yeah, what we have to do here? What we have to do here? Then find the value of one share, of the stock for 2 years from now. So we have n equals to 2. We have to find the value of x, where we have n equals to 2. Okay. So in case we have r equals to 5 and we have a equals to 100, right? Just you have to
Yes, ma'am.
calculate it. So
Okay.
yeah, just calculate this one.
Okay.
Okay, so if you don't have any confusion, then you may leave now. The question in the qualifier answered. Okay. Yeah, you can ask it. If you don't have any doubt, you can leave. If you have doubt, you can ask it. Yeah.
Yes, ma'am, I have sent the question in the chat box. I had a
Yeah.
doubt
So
that
what is
why
your
is
doubt
the
here?
fourth option incorrect?
The fourth option. Which of the following functions are 1, 1? So the fourth option is n minus 1 by 2 if n is odd. And n plus 1 is n is even. Okay. So if we have 3. If we take 3, then it is odd, right? Then the functional value is 3 minus 1 by 2, that is equal to 1. If I take 0, then it will be 0 plus 1 equals to 1. They are not same. But this is same. Got it?
Yes, ma'am. Thank you.
Yeah. Okay. So we can end up the session. Yeah, so you can leave now. If you don't have any doubt, you can leave now.
Okay, ma'am. Thank you.
Thank you.